So this is example number 1. Consider a wind turbine with a rotor diameter of 40 meters and an efficiency of 36%. So if you remember the bits limit, we've discussed this one before, is around 59%. But for this example, the wind turbine is around 36% of efficiency. During one day, the wind is constant 2 meters per second for 22 hours, and then suddenly increases to 12 meters per second. So from 2 meters per second, it increased to 12 meters per second for the last 2 hours of the day. During which period, so the period means this one is the period 1 and this one is the period 2. For which period is the most energy produced? So the word is energy produced. So this is now the problem. So let's put a schematic diagram. So we have a wind turbine here. For example, that's a wind turbine. All right. And then especially at daytime, so it's around 2 meters per second. So most of the day, this is for 22 hours of wind. So this is V1. And for nighttime, so I will just put nighttime here because just to separate the two, this is 2 hours. So let's say 22 hours plus 2 hours is 24 hours. So that's the whole day. So what are the given here? So the first given, as I mentioned, as I showed here in the schematic already. So we have a given of V1, which is the velocity, first velocity is 2 meters per second. Time duration is 22 hours. V2, which is 12 meters per second for a duration of 2 hours. And then we have also given the rotor diameter, which is around 40 meters. We are also given the efficiency, which is 36%. And what else was given? So that's it. These are the things that were given. And we are to find which period. So period with most energy. So this is where we're going to find period with most energy produced. So this is where so what unit are we looking for? So we have to identify first. So this is energy, right? So energy could be in joules, or in this case we are looking for kilowatt hour. So because we are given some time duration for each. Right? So let's try to solve this one. So solution. So what is our main formula for getting the power for the wind turbines, for wind energy? So power is equal to 0.062 kilogram per cubic meter, which is the 1/2 density times the efficiency times the area times the velocity to the power of 3 or cube, V cube. So mainly this is our formula for getting the power of the wind. So if you look at the formula, then we have efficiency is given, velocity is actually given. There are two velocities here, and the other one is area. So area is not given, but we can solve for area because we are given the diameter here. This is 40 meters. So let's try to first solve the area. So what is the area for the wind turbine? So we have pi d squared over 4, which is pi times 40 meters squared over 4. So the area by calculation is 1,257 square meter. So this is the area now of the wind turbine. So now we can solve for the power for each period. So for the power at daytime, so we have the formula on here and we have the area already. So we have 0.602 kilogram per cubic meter times 36%, which is 0.36, which is the efficiency, times the area, which is 1,257 square meters, times the velocity. For in this case, for period 1 is 2 meters per second cube. So now that is the power for the daytime, which is equal to the 2.18 kilowatts. So that is for the daytime or the 22 hours. So for the night time, which is 2 hours, is equal to the same way, 602 times 0.36 times 1257 times the, in this case, a higher velocity. This is 12 cubed, which is equal to 471 kilowatts of power. So you can see from basically from the power comparison, there's a very big difference now. The other one is only around 2 kilowatts. The other one is 471 kilowatts. But the question is about the energy produced. So we have to convert these two into energy produced based on the number of hours of duration of use. So we have to calculate that one as well for good comparison. So to continue the previous ones, a letter C, so energy generated. So for energy generated, there are two periods. The first one is during the daytime, right? So let's say energy generated for 22 hours is equal to, how do you calculate energy? So power times time, basically, right? So if you look at the unit analysis for this, power is watts and time is hours or seconds. So in this case, R. So it becomes watt hour, or you can have kilowatt hour as well. So the same way, we already calculated the power. So what is the first power for 22 hours is 2.18 kilowatts times this is running for 22 hours. All right, so we get the power for daytime at 47.9 kilowatt hour. All right, so that's the power for daytime, or the 22 hours of generation. And the last 2 hours, let's say nighttime, is the same way, but the power is solved as 471 kilowatts times 2 hours. So the answer for this is, what's the answer? 942 kilowatt hour. So you can see a big difference between these two, right? One is 47.9, even though it's running for 22 hours, but the other one is 942 hours, 942 kilowatt hours. It's just running for 2 hours. So if you try to calculate the total energy generated, so how much is the total energy generated for the whole day? Okay, so what's the total? So the total is basically this sum of the two, right? Plus E at nighttime for 2 hours, which is equal to 47.9 kilowatt hour plus 942 kilowatt hour is equal to 989, right? 0.9 kilowatt hour. So this is the total energy produced for the whole day. Okay, so out of this 989.9 kilowatt hour, so let's try to calculate the percentage of the contribution of the 2 hours of energy generated. So what is that one? 2 hours is 942. All right, so energy contribution of 2 hours of last 2 hours. So in this case, for the whole thing, they said 942 kilowatt hour over 989.9 kilowatt hour times 100% is equal to over 95% of energy generated during the short period, which is around 2 hours, right? With the highest velocity. All right, so it means that this problem really shows us the importance or the dependence of the power generated or energy generated based on the wind velocity or wind speed. So even though the wind is only doing it for this period is only 2 hours, but the wind speed has increased so much from 2 to 12 meter per second, then it has also generated the maximum energy even just for 2 hours. So all in all, for 2 hours of energy generation, it accounted for 95% of the total energy generated for this wind turbine. So that's how you explain how the importance of or the dependence of energy generation for wind energy based on the wind velocity.